folks, let's take a look at free response 1. This is going to be an intense question because it's a pretty significant rational expression that I'm going to have to graph. So I would say get your rulers out, get your graphing calculator out. I'm going to do a whole bunch of algebra. But for me, before I even go in on this, I'm going to go ahead and factor this equation. So if I look at this, my function on the numerator, I can see that this is x minus 4, x plus 1. And on the denominator, I can see a GCF of 2. So I'm going to take that out and get x squared minus 16. All right, but then I see that as a difference of squares. So this is x minus 4, x plus 1 over a 2. And then I've got x minus 4, x plus 4. And I can see that there's that factor common to the numerator and denominator. So I want to do the simplified version also and do x plus 1 over 2 times x plus 4. And it might be helpful. I don't know how you feel. You might want to even distribute this out and make it x plus 1 over 2x plus 8. Totally your call. It depends on how into the weeds you want to get. But let's start with our domain and then work our way out from there. So I usually put a little separation here because it's going to take me some time to do all of these traits. All right, so for the domain, I have a fraction, I don't have a radical, I don't have a log, right? So I have that fraction. I'm going to set my denominator to 0. I'm going to take out that GCF just like we said before, right? Or you could divide everything by 2. I'm going to factor this out, x minus 4, x plus 4. And I'm going to see that I get 2 domain issues at plus or minus 4. Now when we get there, one of these will be a vertical asymptote and one will be the x-coordinate of a whole. Because yes, while they both zero out the denominator, one also zeroes out the numerator at the same time. So they show up as different traits on the graph. That's the algebra that links to the graph. But I need to throw out negative 4 and 4 from my domain. So I'm going to go low to high. So negative infinity to negative 4. Negative 4 to 4, and then 4 to infinity. Okay. Now x-intercepts occur when the numerator and numerator only is 0, right? So if I want to find any x-intercept, we always let y equal 0, and in a fraction, that means where is your numerator 0? Now, yes, my numerator does zero out at 4, but 4 also zeroes out the denominator at the same time. That's a different trait. So I'm going to just work off of the simplified version. If I look at the simplified version, right, because I'm just going to say I want to set my numerator to 0. I want to see when is x plus 1 0. Well, that occurs when x is negative 1. Okay, so I'm going to go ahead and say that I have an x-intercept at negative 1 comma 0. And I'm going to write that up as an ordered pair because it's a point on the graph. For y-intercepts, we're always going to let x equal 0. And plug in. So what is f of 0? Now again, I'm going to use the simplified version. You can use the original. That's fine. And it might even just be as easy to use the original. I can see it's going to be negative 4 over negative 32 if I use the original. But let me try the simplified version. So 0 plus 1 over 2 times 0 plus 4. So that numerator is 1. That denominator is 2 times 4. So that's going to give me 1/8. And just as a note, like if I look at the original version, negative 4 over negative 32 is also positive 1/8. So I have 0, 1/8. Okay, great. Again, ordered pair though. I just want to take note that these two always write as ordered pairs. Actually, and include holes in that too. Always write ordered pairs. Okay. Let's go find the VAs. So VAs are going to occur whenever your denominator only is 0. And again, I'm just going to use the simplified version because x minus 4, since it's common to the numerator and denominator, that's going to go in the whole category. Oh, you can't quite see it. The whole is right below the VAs. That's going to go in the whole category. Ooh, you know what? I just realized I got to scooch this up. I'm not paying attention. I was getting too into the math on this. Okay, so when we get there, x minus 4, since it was common to the numerator and denominator, that's going to be a whole. All right, so for the VAs, I'm going to use the simplified version. I'm going to use the denominator here. 2 times x plus 4 equals 0. I can divide both sides by 2. right? And then I want to look for when is x plus 4 equal to 0, and that occurs when x is negative 4. So I'm going to go ahead and write that. There's my vertical asymptote. Now I'm going to write it up as the equation of a line, because vertical asymptotes are vertical lines, and they always come in the form x equals a number. Okay, now I'm going to scooch this up, and we're going to talk about holes, okay? Now for holes, and I'm going to scooch this up for a wee bit, and then I'm going to scooch it down just so I have enough space. All right, when we talk about holes, and can we see this? Yeah, we're always talking about where is the numerator and denominator zeroing out at the same time. And you can see it zeroes out at 4. So when I go right up my hole, and I think we can see this right now, I'm going to put 4 in the x-coordinate, but I need a y-coordinate. And the math behind that, how you find that y-coordinate, is you go ahead and you plug 4 from this factor, 4 into the simplified version, okay? So let me go ahead, I'm gonna push this way up so that I can write all this out for you. And you can also look at the key and find this as well, the handwritten key. Okay, so what I'm saying is if you have a hole, right? Find the factor that zeroes out the numerator or find the x value that zeroes out the numerator and denominator at the same time. Or another way of saying that is x minus 4 is a common factor to the numerator and denominator. All right, and that's why my hole is going to have an x-coordinate of 4. So if I want to find, and I'll just write that, that means the hole is at x equals 4. If I want to find the y-coordinate, plug it into whatever the simplified version is, whatever the remaining stuff is after you've canceled. So my y's are approximately x plus 1 over 2 times x plus 4. So what I'm going to do is I'm going to plug in 4 being x here and see what that y value turns into. So that would be 4 plus 1 over 2 times 4 plus 4. So if I do that, that numerator is 5. 4 plus 4 is 8. 2 times 8 is 16. So there is the y-coordinate of my hole. So let me scooch this down just a bit so we can see this. All right. Now for end behavior, I'm actually going to go back to my original function in this particular instance. Let me scooch this up a little and give myself some space. So for end behavior, all right, if I look at this, the degree in my numerator, it's a quadratic up there. It's a quadratic trinomial. So the degree is 2, it's quadratic. The degree in my denominator, it's also quadratic, but it's a binomial, which is fine, but it's also 2. And when the degree in your numerator is the same as the degree in your denominator, if you go back through all those cases we talked about in section 5.6, it's case 2. But ultimately, y is really driven, at least for end behavior, by the lead term in my numerator in ratio to the lead term in my denominator. So really, the lead term in the numerator is x squared, lead term in the denominator is x squared, and if you canceled out the x squareds, you'd be left with a half, and that's going to be our horizontal asymptote. So I'm going to have a horizontal asymptote at y equaling 1/2. Okay? So in a moment, I'm going to go put all of those traits on this graph. And just while we're here, if I look at the numbers up top, and I know some of them are blocked because I can only get so much in the video, I have numbers like -1, 1/8, -4, 4. So I don't need a ton of space here, but I'm still going to go ahead and make each square worth 10. Not worth 10, sorry, worth 1. All right, but I've labeled and scaled my axes. All right, so if you remember up top, even though I'm not going to scooch, I have an x-intercept at -1, 0. All right, I have y-intercept. Ooh, it's super, super tiny. I've got a y-intercept at 0, 1, 8. I'll just put a little point. It's practically at the origin. I have a vertical asymptote at x equaling -4. Let me go graph that. So let me go to x equaling -4. 1, 2, 3, 4. There it is. Okay. Okay. I have a hole at 5/16. 1, 2, 3, 4. 5/16 is a little bit less than a half. I'm just gonna put the hole there. I must be creeping up pretty slowly here and then probably curving back down to my vertical asymptote. I have a horizontal asymptote of y equaling 1/2. Gosh, let me put the hole even lower. Maybe I should have made these each worth half a unit. Those are such small numbers. Okay, so let's do this. All right. Okay, so I can see the right half of the graph. I have to connect the dots here. And they go up that way, and then they must head down here. Oops, can't cross that vertical asymptote. Let me make this a little bit nicer. And my guess is that the other part will be here. But let me just check. And for me personally, when I go to check these, I always put in my original graph, or my original formula, in case I made a typo somewhere. So I'm gonna type in x squared minus 3x minus 4. I'm gonna protect it with parentheses and divide by 2x squared minus 32. Let's hit zoom 6. And yeah, that little part is up there. This other part's in the bottom right. So I'm gonna go ahead and actually I'm gonna go to my table function. Oops, table. And let's just get a good, if this was at -4, let me go to the left of that. Okay, so it looks like there's an ordered pair at -5, 2. I'll just get a grounding point there. And then it went up like this, came around like that, and there is my graph. Now I gotta do the range. So if I look, I'm going from -infinity, and I have a pause at this y value here, and that y value is 5/16. So I'm gonna start at -infinity to 5/16. And then I go from 5/16 up to a half. It's not that far, because 5/16 to a half, that's just 8/16, but I'm gonna say I go from 5/16 to that that horizontal asymptote of 1/2. Then I hop on the other side of 1/2 and I head up to infinity. All right, so there it is. I found all these traits. I put all of those traits onto the graph. And then once I had the graph, I got the range. All right, thanks so much. Bye.